What up, everyone? It's Miss Butler, and I have a video for you on physical and chemical properties and physical and chemical changes. So our goal today is to be able to use particle pictures to show a physical change and a chemical change, and to be able to tell the difference between a physical property, a chemical property, and then physical change and chemical change. All right, we're going to start by talking about properties. So there are two different types of properties. Let's see if I can move and zoom. There we go. So physical properties. First of all, when you think about physical properties and chemical properties, I want you to think about every chemical as a separate, distinct character in a story. And every character in a story has a different personality. So when I talk about physical properties, I am talking about part of a character, maybe what they look like, some traits, things like that. When I talk about chemical properties, I'm still talking about personality, but maybe now I'm talking about is this chemical or is this person an introvert or an extrovert, or like will they be maybe more withdrawn, are they angry, things like that. So for physical properties, we are talking more about like describing what the character looks like, things like that, part of their characteristics. Whereas chemical properties, we're still describing the chemical, but I think of it as like personality. Okay, so physical properties are the characteristics of matter, and these characteristics can be changed without changing its composition. Okay, and I know that's kind of vague, but these are things we can directly observe. So when we went around and did observations in class of the different types of matter, anything you wrote down was probably a physical property, things you were observing. If I wanted to quote unquote measure a physical property, I observe it, I can measure it, I can get the mass, I can get the volume, things like that. I don't need to do a chemical reaction to observe physical properties. Okay? Whereas chemical properties, these are characteristics that determine how the composition of matter will change as a result of contact with other matter. So again, this is like if I put my character in a room with other characters, how is it going to respond? What is it going to do at a party? Is it going to stand off to the side? Is it going to be the party animal dancing in the middle? Okay, so these describe more the behavior of matter. Unfortunately, to actually test a chemical property, say like I have an unknown chemical and I want to know some chemical properties, I actually have to do a chemical reaction, a chemical change to figure out this chemical property. Once I know it, I know it, but in order to say like it's a totally unknown chemical, to figure out some of the properties, I actually have to mix it with other chemicals, right? If you meet a stranger, you actually have to interact with them to see what their personality might be like. All right, I'm going to list some generic physical properties for you. All right, I tossed up some physical properties that I can think of off the top of my head. We're going to call these extra boxes just suggestions at 5 o'clock this morning. But here are some things that off the top of my head I can think of. And remember, physical properties are things we can observe or measure, and we don't actually have to do a chemical reaction to find these things. Okay, so we got state of matter. Is it a solid, liquid, gas? I put etc. Is it plasma? Is it aqueous? Things like that. We'll get into that later this year. The color, the odor, the texture, the shape, the weight, the mass, the temperature, things we can measure, right? Length, the taste, not for chemicals and chemistry, but again, things we can think about. The sound maybe it makes. Density, right? So how many particles per section of area, that's density. A couple other things I can think of is like melting point, like the temperature it melts, or boiling point, the temperature it boils. Those are things that we can measure, and we don't actually have to do a chemical change to figure these things out. So here are some real examples. So I have a bunch of iron right here. Okay, so let's list some physical properties of iron. Well, it's a silvery solid at room temperature. It has a metallic taste. Please don't lick iron in our class. And it can, in this case, have a smooth texture. Iron melts at 1,538 degrees Celsius, so that's the temperature we can get it to go from solid to liquid, and it boils at 4,428 degrees Celsius, so the temperature it goes from liquid to gas. It has a density, so 7.87 grams per centimeter cubed, so every 1 centimeter cube block like this It will weigh 7.87 grams. It can be magnetized. Ooh, that's an interesting physical property, if something's magnetic or not. And it conducts electricity, but not as well as other metals. So conducting electricity, can we get an electric current to run through it? That is also a physical property. So here's two more for you: magnetized and conducting electricity. You can add those to your list. All right, so now I think the more challenging of the two, chemical properties. So remember, these are like personalities. So you can't have a chemical property unless we interact this chemical with other things when we're testing the chemical properties. All right, so here's some chemical properties that I can think of off the top of my head. Flammability, if something can basically react and start a fire. And then like my go-to if I'm ever stuck is reactivity. Reactivity with acid. Like say we have chemical A, I want to know if it reacts with an acid or not. I dump acid on there and see what happens. And now I know moving forward, let's say it does react, that chemical A is reactive with an acid. So again, the property is, does it react with an acid? But to actually figure it out, like I can't just look at the chemical and know. I actually have to dump acid on it and see what happens. Toxicity, so how much a human or another creature can consume before it hurts us or causes problems. Will it react with water? See, I like the reactivity one. That's my go-to. Combustible, so will it react with oxygen, right? That kind of goes with flammability a bit. Acidic and basic is also one, so like knowing the pH and if it acts like an acid or a base in certain chemical reactions. Those are all chemical properties. So back to iron, okay, we did physical properties of iron. Now here's some chemical properties. It's oxidized, in moist air to form rust. So that's another property, oxidation. Oops, struggle today, guys. Let's try that again. Don't talk, just write. Okay, that just basically is a type of reaction that we learn about in chemistry. So will this chemical be oxidized, or will it, you could even put the word reduce, that's the opposite. So when it's added to hydrochloric acid, it produces a solution of iron 2 chloride and hydrogen gas, aka it reacts with the acid. So it has a reactivity with the acid, and it is more reactive than silver, but less reactive than magnesium. So we can also do comparisons, right? Is it more or less reactive than other chemicals that maybe are similar to it? Okay, so here's your practice, okay? And I really want you to pause the video. So pause the video. Here's a bunch, and you should have them on your notes page. If you're in my class, I gave you a notes page. So you should have these on a note page, or you can just jot them down. And I want you to pause the video and tell me, are these physical properties or chemical properties? And then I'll be back in a second with the answers. But I really want you to try on your own. That's the only way you know if you understand those last few slides. All right, half of you listened to me. Thank you. The other half did not. That's fine. You're probably just not getting better. It's all right. I'll let it go. Okay, so here we go. Salt is white solid. That's a physical property. The melting point at 801 Celsius is a physical property. It's stable at room temperature, so stability, and if something will decompose, that's a chemical property. 36 grams of salt will dissolve in 100 grams of water. That is physical, so solubility, how much can dissolve in water, that is a physical property. Salt solutions and molten salt conduct electricity. We talked about conducting being physical. When a clear color solution of silver nitrate, I hear another chemical that means we're testing how it responds at a party. It is added to a salt, a white solid forms, so that's chemical. When electricity is passed through molten salt, a gray metal forms at one terminal and a yellow-green gas forms at the other. That's chemical. We're doing a reaction to test what happens when I break up the chemical with electricity. So not yes or no, it conducts, but when electricity runs through it, what happens? That's a chemical property. All right, part 2 is a little easier for kids to understand. It's physical and chemical changes. So I'm actually doing something. I'm not just describing a chemical. I'm actually doing something, and it's going to be classified for us as either a physical or chemical change. Just so you guys are aware, this is kind of a continuum, right? There are some gray in between areas, but for our class, we're really going to try to separate and commit to a category. But if you take college chemistry, there might be a little in between or gray area. So some changes in matter. Physical changes will change some of the properties. some of the physical properties potentially, okay, but it does not affect the composition, so it won't impact the chemical formula. Okay, here's the key part I need you to walk away with. In a physical change, chemical bonds are not created or broken. We are just rearranging matter. Okay, whereas chemical, we change, again, the properties of matter, which could be now chemical properties of matter, and it changes the composition. So the chemical formulas are going to be different. And here's the part I need you. If you walk away with anything, it's this highlighted guy. Chemical bonds are created or broken. Okay? I want you to move away from your middle school definition. For physical changes, we do not create or break bonds. For chemical changes, bonds are created and or broken. So I could be making bonds, breaking bonds, or some combination of both, but that has to happen for it to be a chemical change. So there's a tiny problem, okay? Turns out my eyes are not very good. Yours are not very good. We cannot see bonds being made and or broken. No matter, like in this class, none of you will be able to see bonds being made or broken. So that's not very fair of me to say a chemical change is when bonds are made or broken, a physical change is when they're not, but you can't even see if the bonds are made or broken. So we need some evidence, right? If I'm going to say that I have a claim that there is a chemical change, I need some evidence, right, that I can actually see with my own two eyes. Okay, so here are the 6 signs that there is actually a chemical reaction happening. 6 signs that bonds are being made or broken. Is there a change in temperature? And I'm not just talking like, oh, I put it on the hot plate and it warmed up, or I used a Bunsen burner. I'm talking like we mix 2 chemicals and it gets warmer on its own, or I mix 2 chemicals and the temperature drops on its own. Is there a dramatic color change? Okay, obviously there's some exceptions to these, so I need you to use some common sense, right? Putting marker on a piece of paper is not a chemical change. Putting food coloring in water is not a chemical change, right? Red food coloring, clear water turns red, not a color change. But if I mix something, 2 clear things, and it turns bright yellow, that is a color change that I'm looking for. Odor change, if it's giving off some strange smell, right? It started with no smell and now we have a weird like rotten egg smell or anything like that. If a large amount of light is produced, okay, a large amount of light, it glows on its own, that is going to be a sign of a chemical change. If there's bubbling, I mix 2 things and all of a sudden you see bubbles, that means a gas is formed, a new chemical, bonds were made or broken. And the last one is a special vocab word I need you to know. It's called precipitate. So it means a solid is formed. And that does not mean that there was a solid to start. What I mean is I mix 2 liquids together and I start to see some cloudiness. So I'll show you a picture. It's not like a chunk falls out necessarily. I'll show you what it kind of looks like when a precipitate forms. So here's a couple of the examples. This one we see bubbling, right? So that's the evolution of a gas. Tiny bubbles like that means we're forming a new product, new bonds were made or broken, or bonds were broken and new bonds were made. So we get bubbles. Here's a good one for evolution of light. That chemical reaction is glowing. And then here's a precipitate. So say like I have chemical A and chemical B and I dumped them together. Do you see all those tiny, tiny cloudy particles? That is a precipitate. Those are tiny solid particles that are now floating in the liquid. So that is one of the signs that bonds were made or broken, a chemical change. All right, here are some examples for you of physical and chemical changes. So physical, remember, bonds not made or broken, matters just rearrange, okay? So no bonds changed. So a phase change, and I put some examples for us. Boiling, when we go from a liquid to a gas. In that case, the particles are just spreading out, right? We're not breaking bonds. The particles are just moving away from each other. Freezing, they're moving closer when we go from liquid to solid. Melting, those particles are spreading out again, solid to liquid. And condensation, gas to liquid particles are moving closer. When I dissolve something, we're going to call that a physical change for this class. When I cut something into a smaller piece, okay? Separating mixtures. So remember, mixtures have different types of particles all in the same box, right? So I got my square and my circles and my dark circles. So if I wanted to separate the square and the circle, right? Say like I want to separate into this. and the other piece is separated. I could use a magnet if one of those is magnetic, right? Get the magnetic pieces. I could filter if one's a liquid and one's a solid. I could use some filter paper. We learned how to do that at the beginning of the year. So pour the liquid and the solid through the filter. The solid sits on top, the liquid goes through the paper. We could boil if these are two liquids with different boiling temperatures, okay? We could do chromatography, which we'll learn about this year, distillation. So again, just any separating of a mixture is a physical property, okay? Some examples that we'll see of chemical changes. Again, we will observe the 6 signs that bonds are made or broken, right? And or broken. Okay, so burning. What happens when we burn something is oxygen from the air actually comes and attaches with the substance we're burning. So we are making new bonds when we burn something. Decomposing. So if something is breaking down, we're actually breaking apart, breaking the bonds in that compound. Rusting, things like that. Okay, there's tons of chemical examples. That's like this whole year is us learning chemical reactions. But I just wanted to give a couple that you've probably seen before in your life. Okay, last but not least, we have to be able to draw particle pictures for these. So when you draw your particle pictures, we follow the rules for drawing them, okay? But here's the key for physical changes. I have to see no bonds made or broken. The particles are just moving. So in my before picture, I have 4 water particles and 3 salt particles outside, meaning they're not mixed yet. And in the after, notice I have the salt particles evenly spaced with the water particles to make a homogeneous mixture. No bonds were made, right? I didn't break any of the bonds. I just mixed these two things together. If I had to write this as kind of a chemical equation, so to speak, it would be that I have, let's go to the pen, H2O liquid plus NaCl solid just is going to make H2O and NaCl, okay? And again, we wouldn't really write a reaction for this because it's a physical change. I suppose, let's pretend for a hot second, let me see a more typical one. Let's say I wanted to melt an ice cube. So I have solid water and I want to melt it. Here is a kind of more realistic reaction, right? I start with the solid and it melts to the liquid. So those are my states of matter, solid, liquid. But notice, like, there's no new arrangement of the H's and the O's. They're all in the same pattern that they were before. Okay? Chemical changes. Bonds must be made and or broken. So here I have one chemical, potassium fluoride. And I have sodium bromide. I showed that they are separated with the line in the box. And then when I mixed, notice I broke these bonds. And I made a new bond between the teal and the purple and between the orange and the yellow. So this reaction would look like this. KF plus NaBr makes now a new one, NaF and KBr. In this class, I do not expect you to know what the new chemicals are called. I expect you to show me that some bonds are broken and some new ones are made, or at least one of those combinations. Okay, so in our class, if you want to call this new particle, right, so we draw the shape, but we call it new particle A, and we call this new particle B, I'm good with that until we learn about the types of reactions and who's actually going to bond with who. Hopefully this was helpful.